Hi everyone, welcome back to Coding with Bharat channel. So today we had the Leetcode Weekly 388 contest, and I'm going to discuss three problems of this contest in this video. There will be a separate video for the fourth problem that you can check it out also on the channel. So yeah, it was an interesting contest. I would say all the three questions, the first three questions were majorly not having any new concept. It was more of an implementation. Fourth problem was an interesting one, but the problem statement was unclear. So yeah, kind of like a okay-ish contest, not the best of it. So yeah, let's get started. Let's try to take up all the three problems in this and fourth problem in the next video. Okay. So let's start with the first one. First one says you need to redistribute some apples into different boxes. So let's go through the problem quickly. So it says that let's say you are given first an array known as apple of size n and another array of capacities of boxes of size m. So there are two arrays. One represents the different apples that are there in currently in some boxes. Another array that gives you different boxes and their capacities. Now you want to take out the apples from the existing boxes and put them into minimum of the capacity boxes, right? So as an example, if you look at the example number 1, there are 3 boxes with 1, 3 and 2 apples. Now you have new boxes which are given in this capacity. So what you can do is you can take a box of size 5 and put 3 and 2, like 5 apples into that. Next, probably you can take another box of size 1. So there is 5 and there is 1, right? So just a box of size 1 and put that 1 apple there. So you'll be done. So minimum in 2 boxes, you can get the job done. So that is what the question is all about. Okay. Yeah. If you are seeing this problem for the first time, probably just pause the video here and try to come up with a solution on your own. If not, then let's get started. So let's go to the whiteboard. Okay. Now let's say we have certain apples with us. So 7, 3, 1, 2, 5, right? So some different apples. Now, if there are different boxes of different sizes, 7, 8, 11, and we want to minimize the number of boxes, can I take an observation and say it is always best to take the biggest box, because then you can store the maximum apples in it and now you'll be left with lesser number of apples with you. Remember, the question says you don't need to necessarily fill the entire box. It can very well happen that, let's say, if the total number of apples also are 10, and let's say you have a box of 12 capacity, you can put those 10 apples in those 12 capacity box, right? Because it is not necessary that you have to fill a box entirely. Okay, so that is actually there in the question. So that simplifies it a lot. Now what we can always do is pick the biggest box, because picking the biggest box always will take in the most apple, and then take the next biggest, and then take the next biggest. So in a way we can arrange the available boxes by their capacity in descending order. So what I'll do, I'll arrange this 11, 10, 8, 7, 2. First I'll try to pick this 11 and put the maximum apples into it. So total apples that I have, 7 plus 3, 10, 10 plus 5, 15, 17, 18. So 18. So out of these 18 apples, 11 at least I can put it here and be left with 7 of them. And then pick the second box and put those 7 in. Now 3 are left in that box, but that is perfectly okay because we can keep the box half filled. So answer is 2. So simply saying, first sum up how many apples are there, right? Once you have how many apples in total you need to put into the boxes, take the maximum capacity box, then the next, till sum of the capacities is able to accommodate all the sum of the apples, right? So here if we see 11 plus 10, 21, is more than the total apples that we have, which is 18, more than or equal to. So that is where we can stop, and these are the number of boxes that we would need. Okay, so let's just see this in the form of code as well quickly. This was actually a little bit trickier first problem than generally what we see. Like generally we don't see even sorting etc in first problem. So I would say, actually I would say first, second, almost third were of the similar kind of level. But yeah, not a super easy problem, like probably returning a small number or doing some if else cases or just running a for loop, right? Not that kind of a problem. You had to think that you will take it in the reverse order, sort it, and then use it, right? Okay, so let's go to the summations and look at this particular summation. Okay, so what I've done here, first I've calculated sum of all the apples. So just one loop on my apples array and just calculating the sum. So I now know the total number of apples that I want to put in the boxes. Next, I have sorted the array, and since sort generally sorts it in increasing order, you have to reverse it to get it in decreasing order. If you want, you can also use r begin r end, right? So instead of this begin and end, you can do r begin r end. That automatically sorts it in reverse order. Okay, so once we get it sorted, then start from the 0th place and keep taking one by one the boxes. So I'll say current sum is 0. You go over the capacity of sizes, add it to the current sum. If at some particular point you see that you are able to accommodate all the apples, you break from there, right? So that is what I've written. If the current sum, like taking boxes one by one, if the total capacity increases or is greater than or equal to the total number of apples that we have, we break from there. And now whatever our I is, we have to take that many boxes. So I have returned I plus 1. Why I plus 1? If let's say only taking the 0th box got us the total number of apples, then answer will be 1 because we have taken one box. Similarly, if till 1 we got the answer, that means two boxes are there, 0 and 1. So that is why I plus 1 here. Okay, so that was the simple solution of the first problem. Let's move on to the second one now. Okay, coming to time and space, just to quickly do that. Time complexity of this approach is in fact n log n because you are sorting. You're sorting the array, so it is n log n. If we talk about space, we are not taking any extra space. We are just sorting the same array and reusing it, right? So no extra space required. Cool then. So that is about time and space. TC is n log n, space is O1. Let's go to the second problem, which was also kind of similar to the first one, right? So let's get that started. So the problem says we are first of all given an array happiness. So we have n children and we know happiness of each child at the moment. Okay, now it says that at every moment what you can do is you can select exactly one child, right? You select exactly one child and add that child's happiness value into your answer. So there is an answer which is 0 initially. You add the happiness of that child into the answer. And what will happen is all the other children that did not get selected so far, their happiness will decrease by 1. So as an example, if in this array I take the second child with me, so basically 2 is added to my answer. Rest of the people will get -1. So 1 will reduce to 0, 3 will reduce to 2. Okay. Next, probably what I can do is I can take again the child with 2 happiness now because the 3 one has been reduced to 2. So I'll get 4 as the answer. And that third one will reduce to again -1. But question says, note that the happiness value cannot become negative and gets only decremented if it's positive. So that will not become -1, that will stay 0. Okay. You have to do this for k turns. So you have k turns to maximize the happiness that you collect. Okay. So you have to collect the happiness and get the maximum value. For example, in this case, when k is 2, I can get 4. I have already told you. Here, if k is 2, you take any one child Rest of them becomes 0. So you cannot take. Like even if you take, then 0 will be added. So answer is 1. Can only take 1. Here we just want to take 1. So best to take the maximum one, which is 5. Okay. Cool. So again, if you have not done this question before, just pause and try to think what you can do. Otherwise, let's get started. Okay. So if I have certain happinesses in an array, right? If I have something like this and I want to take exactly one child, then can I say my answer will always be the maximum one, because that will give me the maximum value, right? If I want to take just two child, even though the second child will get a -1, can I still say it is always and always best to take the top two, 10 and 7? Why? Because if you take something else also, 10 and 2, then that will also get a -1. So at the end of the day, if you are taking ith and jth element, your answer is going to be array of I plus array of j -1, right? So why not take the two which are maximum? Because -1 is anyways going to come into the picture. And -1, when will it not come into the picture? When only the answer has already become 0. But then nothing is added to your answer. So in a way, I can say always and always it is best to take from the maximum happiness to the minimum happiness. So again, it boils down to taking and sorting this array on happiness in reverse order. So if I reverse it, so I'll get 10, 7, 5, 4, 3, 2. And I can simply start picking from the starting. So if k is, let's say, 3, then I'll pick this 10 plus. When I pick the next one, it would be -1 because one person has already been taken. So it would have got a -1. So 7 -1 plus 5 -2, because now when 5 gets picked, 2 of them have been deducted. Okay. Let's say if k was 5 instead in the same array, then when I take the next one, 4, 3 have already been taken. 4 -3. When I take the next one, fifth one, then 4 have been taken. But if you think about it, 3 -4 means 4 have been taken. So this 3 would have been reduced to 2, 1, 0, -1. But it cannot go to -1. So whenever you're trying to pick a negative element, that means everything in the future has been reduced to 0. So you can just add 0 and continue. So just a small thing to note. Okay. So basically sort the array in the reverse order, take from the start and keep on adding array of I minus I. Why minus I? When I is 0, we are not minusing anything. When I is 1, we are subtracting 1 from it. When it is 2, the index, we are subtracting 2 from it, right? So yeah, array of I minus I, you need to just keep on adding. If array of I minus I is actually 0 or less than 0, then you take 0 only, right? Okay, so let's get into the code again. So my submissions and accepted. Sort the array and reverse it, or if you wanted, you could have done r begin r end again to get the reverse order. Now you declare the maximum answer that you will get as 0. You start iterating and keep on adding happiness of I minus I, that is array I minus I. If that ever becomes 0 or negative, then you need to add 0. So you say maximum of 0 and this difference. So if this is negative or 0, then you will take 0, right? So that is why you take maximum with 0. And finally you return on this S. So code wise, lot simpler also than the first problem. Logic wise, slightly tough, but again, on the same level, I guess, both the problems. Great. So if you're clear so far, let's move on to the third one. Before that, time complexity of this and log n. Space, again, we are not taking any extra space, so O1. Let's go to the third one. Okay. This was, I would say, more interesting and more tougher problem than the first two. So yeah, pay attention. So this one says, let's say we are given an array having some non-empty strings. So an array of strings with us like this. Now, for each of the string, you need to calculate an answer. And what is that answer? That answer would be shortest substring. Shortest substring. So first of all, if I have a shorter substring, then that is the better answer. Shortest substring that does not occur as a substring in any other array, any other element of the string array, right? So as an example here, so if I take length 1, which is the shortest, C occurs in the fourth string, so that cannot be the answer. A and B also occur in the relevant string, so A occurs in this also A and B both occur. So one length strings are not possible. Let's take two length strings. So CA doesn't occur in any of them, so CA could be a possible answer. AB also doesn't occur anywhere as a substring, so AB also could be a possible answer. So two length, and we have two options, CA or AB. So if we actually check out, it says if multiple such substring exist of the shortest length, then you should take the lexicographically smallest one. So basically, if I compare CA and AB, the answer is obviously going to be AB because it is lexicographically smaller. Lastly, it says if no substring exists, then it should be empty. So as an example, if I look at this AD, then one length A is there in a lot of them. D is also there in this. AD is also exactly there. So even one length, two length, nothing is possible. So answer is empty. Okay. In the third one, I had two options, BA and AD, but AD exists here in the second string. So that means BA was the only possible answer, although it's lexicographically greater, but still we'll pick that. So BA would be the one picked. Okay. So that is what the question talks about, right? So let me just go to the whiteboard and summarize it. So for any string S, find shortest substring such that it doesn't exist in others as substring in others. Now there are some tiebreaker rules. If there are multiple shortest, lexicographically. Lastly, if there is no shortest, then empty. Okay. So let's think about first the brute force idea. What could be the absolute brute force that we can do? So absolute brute force would be something like this. What we can do is, for any string, let's generate all substrings, right? So first we'll start with one length substrings, generate all the one length substrings, then two length substrings, then three length substrings. For each of the substring, let's see if they are substring of others. So go over the remaining strings and calculate if this exists in other substrings or not, right? So that could be the brute force. So let's see what will be the time complexity of this. So first of all, you need to calculate the answer for all the strings. So this entire thing will happen n times. N is the length of the array or length of the original array, which is the total number of strings that we have. I'll call n as array length and L as string length because they are different in the question. So I'll use n and L here. Okay. So n, go over each of the string. For each string, generate all the substrings. So any L length substring, any L length string will have L square substrings, because you can fix any one index in the substring as starting and any other at the ending. So for example, if we have ABCD, we could have any ending and any starting. So two pointers essentially to fix a substring. So there are L square substrings. So for each string, generate the L square substrings. For each substring, go through the entire list again. So into n for each of the substring, and check if that is there in the string as a substring or not. So again, that is O of L. So actually, if you see, the time complexity of this was n square L cube, right? Our n was 100 and L was 20, right? So actually it would be 4 into 8 0 0 0. So 3 and 2, 3 and 4, 7, 8 into 10 to the power 7, which was difficult to pass into the time complexity, right? So 8 into 10 to the power 7, which was not possible to pass in the complexity. Okay. Now, there could be optimization of this brute force itself, like you can use tries, you can try to use some complex algorithms, right? But there is a very simpler solution than using all those complex things, by just thinking of the same question in a different perspective, right? So let's get to that. So I had multiple strings, right? So for example, ABCD, then let's say I have AC, then let's say I have BD, then let's say I also have AAA, BBB, right? Okay. Now, if you think about it, I want to find those substrings that are unique, those substrings that are only there in one of these strings. So as an example, if I talk about A here, double A, then that is a unique substring that is only and only present in one of my list elements, right? So what I can do is I can generate all substrings of every string, right? So for example, for this, I'll generate A, B, C, D. I'll generate A, B, B, C, C, D. Then I'll also generate A, B, C, B, C, D. I'll also generate A, B, C, D. So all these substrings. Similarly here, A, C, A, C. Here B, D, B, D. Here A, double A, triple A. Here also B, double B, triple B. And I'll only and only be interested in those substrings which are unique in nature, right? So I think my face is hiding the third one. So I'll just move myself the bottom right. Okay. So for the first string, we have A, B, C, D, individual 4 characters, A, B, B, C, C, D, A, B, C, B, C, D, A, B, C, D, right? All of them. Second string, A, C, A, C. Third string, B, D, B, D. Fourth string, A, single A, double A, and triple A, right? Similarly, last string, single B, double B, triple B. Okay. So I'm only and only interested in those substrings which are unique in nature. So if I think about it, A is not unique, so I can remove it. Similarly, B itself is not unique, right? C also, if you see, is available in a lot of places. So C here, then yeah, 2 places only. Similarly, D also, it's here also in BD and here also. So we can remove all the strings which occur more than once and only keep those which are unique. So AB, if we think about it, so it occurs once. Does it occur anywhere else? Answer is no. So this is a unique one, right? Then this is also a unique one, I think. BD is also a unique one. Double A also and double B also. So we directly get our answers for each of the strings. So basically what I'm saying is, first what let's do is to generate, I'll mention the data structure, a map from string to something which lets us keep a track of where all this substring exists, right? So I'll probably take a set of my integers. So what is this set? This set is all the indices of my array where this given string is a substring. So for example, in the above case, for a string, my map would contain index number 0 because 0th string also has a, index number 1 because 1th string also has a, and then index number 3 because 3rd string also has a, right? So a map from each string where all it occurs as a substring, right? So once I have this map, I will only and only be interested in those strings which have a single element in their set, right? Okay, you can think why I'm using set, why cannot I use a int for my frequency? You can do that because why am I doing this? Because then you will also be able to get from that single length string, single size set, sorry, that where this occurs as a unique element, right? So let's see this in action. I'll directly jump onto the code because rest of the part is relatively simpler. So what I've done, I have taken a map of string to, so for every substring I want to know a set of my positions where all this string exists. Now for each of the string in my array I am calling populate map. So find all the substrings of this array of I, right, and put them into map. So if you look at the function, what it is doing, it is trying to find two indices that okay, I equal to 0 to n, j equal to I plus I to n. So fix the 2 points, get that substring, and in m of temp, because that is a substring of ours, insert this index, right? So I have my map saying that okay, this string is a substring in these indiced substrings, these indiced strings of the original array. Okay, so now that I have this, I now just need to create my result. So I've initialized it to empty. If some of them don't have anything unique, they would be defaulting to empty. Now what I'm doing is going over the map one by one, all the elements of the map, seeing if the set corresponding to that string has size more than 1. If yes, then continue, because now there are more than one element having this string, so we cannot take it. We can only take those having exactly one string in their set, one index in their set. Okay, so otherwise if it's 1, that means for this particular string that correspond to my current position in map, I have only one index available in my map. So what I'm doing is I'm getting that index. So from that map, get the begin and extract out the index at that position. If the current answer for that index is empty, then just replace it. Otherwise, if that index had more unique strings in the past, I want to apply the conditions given in the question. So if existing answer has more length than my new answer, so we had to find the shortest one. So I'll replace it with the new answer. So I'll say it's the new one. Remember, whatever we are getting from here are directly unique. So unique is already defined. Now we want to find shortest, and if there are multiple shortest, then lexicographically smallest. So I'm saying if the new answer has shorter length than the old answer, then replace it with the new answer. Otherwise, if again lengths are same, but the old answer is more than or is lexicographically more than the new answer, then also replace it with the new answer. So yeah, just going over the map, all of them that have only one element, take that, go to that position. If there is no answer for that position, just put this answer. If there is an answer of length larger, then also put it. If there is an answer but it is having same length but it is lexicographically more, then also put this into the answer, right? And finally we'll get our entire result array. So in this way, what we are doing, so let's talk about time complexity as well. So we are going going over each string. For each string, we are populating the map. So what is populating map doing? It is doing L square to fix the 2 points. Then L cube actually, because we are getting the substring also. So one more L. So L cube. So N into L cube, which is still fine. And putting it into the map. Next, this part is again just going over the entire map once into L. So entire map can at max have L square elements because N square substrings for each of them. So N into L square at max if everything is unique, and again into L for comparing. So actually if you think about it, time complexity is N into L cube, right? So if we compare it with our previous one, that was what? L square into, yeah, so L cube actually, L cube into N square. So we have reduced a factor of N and now we are just dealing with N into L cube. So yeah, this will definitely pass into the complexity because we have reduced 2 zeros. So it is just 8 into 10 to the power 5. Great then. So that was all the 3 questions that were there in the problem set. 4th question, interesting DP problem. So we'll take up DP as the topic of the week also. Specifically this kind of DP where we are dealing with previous element. So yeah, let's see you in the next video where we'll go ahead and talk about the 4th problem, which is the DP problem here.